Welcome to the problem section for this section on velocities. And there really are no new concepts, and that's why I didn't do a lecture either for this one, and we're just going to have a small number of problems, and they're going to be really quick. It says, find the distance as covered by a point moving with linear velocity of 20 feet per second for a time of 4 seconds. And then it's just multiplying the two numbers, so 20 feet per second times 4 seconds. And of course the seconds are canceling, we come up with feet, and that is 8 feet. Travel at a speed of 20 feet per second for 4 seconds. You have covered 80 feet. And the next problem is just plugging in different numbers. 10 feet per second times 4 seconds comes out to 40 feet. Then traveling around a circle, the equation is pretty much the same. The angular velocity equals the angle over time, and that's why the other equation was introduced first to show the similarity. So it says, point P sweeps out a central angle theta as it rotates on a circle of a certain radius. In each case, find the angular velocity of the point P. So we're just going to plug in the numbers. Omega, oops, I already did that here. Omega is going to be the angular velocity times, oops, here's the times the time okay, well in this case it's divide by time. That's where I confused myself. The previous example was multiply speed times time. Here it's actually divide angle by time to come up with the speed. So it's divide by 5 seconds. Let's see. Okay, let's see what I made. My mistake is in the units here. There we go. That's not supposed to be there. So this one is actually radians. Divided by 5 seconds. And we simply come up with 2 pi over 15 radians. So I'm going to write that down. 2 pi over 15 radians per second is the angular speed. And if we wanted to write that as in decimals, we come up with, I do this on the side, 0.419 radians per second. And the other problem looks virtually the same. I'm getting rid of this here. This just confused me a moment ago. So here we have said for the angular velocity, we come up with 3 pi over 4 divided by 5 seconds, and we come up with 3 pi over 20 radians per second, and then we plug that in and we come up with 0.471 radians per second. So as I said, it's just a matter of plugging in the numbers, and of course you're familiar with that. And that was it for this problem section.